When we think of like a green future, we always seem to picture the exact same glossy
Oh,
brochure.
yeah, totally. The gleaming white wind turbines, clear blue sky.
Right, exactly. Solar panels neatly integrated onto every single roof, like a shiny electric car just sort of silently gliding down this pristine tree-lined street. It's this incredibly clean, almost, I don't know, frictionless utopia.
It really is. And it feels inevitable when you look at it that way, right? Like we like our progress to be visible and categorized and tidy. The assumption is that it's just, a matter of time.
Yeah.
A few policy tweaks, a couple of software updates, and boom, we arrive at that perfect destination.
But then you start looking at the actual plumbing of this transition.
Mm-hmm.
And I mean, the raw, unforgiving physics of the electrical grid, the brutal macroeconomics of global supply chains, the industrial reality, and suddenly that shiny brochure just catches fire.
Yeah, it really does.
You realize we might be looking at a landscape that is deeply fundamentally broken. And okay, let's unpack this because that is the mission for our deep dive today. We are unpacking a fiery, complex, and I'd say deeply revealing roundtable discussion from a Dutch YouTube channel called The Nieuwe Wereld. So the New World.
Right.
And the title of this specific debate alone sets a really heavy tone. It's called Economisch Zelfmoord door energy transity, which translated means economic suicide by energy transition.
The stakes here, they really couldn't be higher. In mainstream discourse, the transition to green energy is universally treated as an absolute necessity, like a moral and practical imperative.
Definitely.
But this source material, it dares to ask the profoundly uncomfortable questions about how this transition is actually being executed on the ground.
Yeah, and in this debate, we have four very distinct, highly experienced voices colliding. First, there's a macroeconomist, and he is focused entirely on the raw, unforgiving costs to society.
Right, the financial bottom line.
Exactly. Then we have an entrepreneur and former politician who is actually an electrical engineer by trade, so he's focusing on heavy industry and the actual grid physics. Third, there's this investigative thinker whose main goal is to shatter the myths surrounding our power grid. And finally, sitting right in the middle of all of them is a relentless green innovator who believes the solution lies in, decentralized power, even if the government is getting in the way.
And before we dive into the mechanics of their arguments, we need to be incredibly clear with you, the listener. The source material we're analyzing today contains some highly politically charged views.
Very much so.
The speakers offer sharp critiques of government policies, European Union climate regulations, bureaucratic directives. Some even refer to current European policies as neo-communism.
Yeah, that term gets thrown around.
Yeah.
And our role here is purely to impartially map out these arguments and ideas for you. We aren't, endorsing any specific political side, left or right.
Right. Absolutely not.
And we aren't validating the political rhetoric either. Our job is simply to take you inside the source material, convey the mechanics of their arguments, and help you understand the core ideas these four individuals are debating. Because regardless of where you sit on the political spectrum, we want to tease you with a totally counterintuitive claim right out of the gate from this source.
Which is a huge one.
Right. What if the current top-down energy transition is actually harming the natural environment while simultaneously bankrupting the economy?
It sounds totally paradoxical. How could trying to save the climate destroy the environment? But when you start pulling on the threads of grid capacity and international manufacturing and basic physics, well, the picture gets incredibly complicated very quickly.
It really does. So let's pull on that first thread. The most immediate crisis mentioned in this debate, and the one that really anchors the whole conversation, is the stalling of the electrical grid. They call it net congestion.
Yeah, net congestion.
And the numbers they drop are just staggering. According to the source, there are currently 15,000 businesses waiting for a grid connection in the Netherlands alone.
15,000 businesses. Just think about the cascading effect of that, right?
It's massive.
That means bakeries that can't turn on their ovens, factories that can't expand their production lines, housing developments that simply cannot be built because they physically can't get power. The economy is essentially hitting a brick wall, and the financial cost to fix this wall. The source cites an estimated cost to upgrade the grid of between 235 to 269 billion euros.
I am really trying to wrap my head around that number. €250 billion just for cables and transformers.
Exactly.
Because the mainstream narrative, which I hear all the time, is that this is a consumer behavior problem. The story goes that the grid is completely overloaded because everyone gets home from work between 4 p.m. and 9 p.m.
The classic peak hours.
Right. They plug in their electric vehicles, they turn on their induction stoves, they run their washing machines all at the exact same time. Like, you, the consumer, are overloading the system.
But Bert, the investigative thinker in the debate, he throws a massive wrench into that narrative. He flat out says the data does not support this.
Really?
Yeah, he points out that overall electricity consumption is actually decreasing. We are consuming less electricity collectively, not more.
Wait.
And furthermore, we are not demanding more power between 4 and 9 p.m. than we used to.
Okay, wait, I'm losing the thread here. If we are using less power overall, how in the world is the grid congested? I mean, how do we have 15,000 businesses stranded? If the pipes have less water flowing through them, they shouldn't be bursting, right?
Well, the problem isn't the volume of the water, it's the direction it's flowing.
Ah,
Rob, the engineer in the room, he steps in and explains the actual physics of the problem. It has nothing to do with the amount of electricity, but rather the architecture of the grid itself. The grid was historically built for centralized power flowing one way.
okay, let me see if I can build on Rob's engineering logic here. So historically, you had a massive coal or gas plant, right?
Right.
That plant generated massive amounts of electricity and pushed it down through giant, thick cables, distributing it out to the cities, then to the neighborhoods, and finally down a tiny wire into your house.
Exactly, a one-way street.
Right, a one-way street from the center to the edges. But now, with solar panels on every roof and wind turbines in random fields, power is flowing from all directions. It's pushing back into the grid from the very edges of the network.
Yes. And that inverted architecture creates a catastrophic problem for a concept engineers call selectivity.
Selectivity.
Right. Rob explains selectivity using a very relatable example in the text. The grid's safety mechanisms, they basically rely on a hierarchy of fuses and breakers.
Okay, so if I have a short circuit in my kitchen, say my toaster catches on fire.
Hopefully not, but yes.
Right. So the local fuse in my own meter box is supposed to blow. That local fuse isolates the problem. The absolute worst case scenario is if a short circuit in my kitchen somehow bypasses my local fuse and trips the high voltage switch for my entire neighborhood, plunging 10 blocks into darkness.
Precisely. The system needs to isolate faults locally, but when power is surging into the grid from millions of random, unpredictable directions from every solar panel and local wind turbine, managing that selectivity on a massive national scale becomes incredibly complex.
Because it doesn't know where it's coming from.
Exactly. The grid's safety mechanisms just get confused. If a fault occurs, the system doesn't always know where the power is coming from because it's literally coming from everywhere. The physical cables, the transformers, the switches, they cannot safely manage the chaotic, decentralized direction of the new power flow.
So to fix this architectural mismatch, we aren't just adding a few more wires. We are looking at spending up to 269 billion euros to completely rip out and redesign the nervous system of the country.
Yes.
And not even to generate a single extra watt of power, but just to manage the traffic jam of decentralized green energy.
That's the reality of it. And if we connect this to the bigger picture, this is where the macroeconomist in the debate, Keyes, drops a really sobering reality check. If society is forced to spend hundreds of billions just to upgrade cables, who pays for that?
Right. Where does that money come from?
Well, Keyes states a core macroeconomic rule. Economic welfare is built on exactly two things. Two flavors, as he calls them, affordable energy and reliable energy.
Wow. There are no other flavors.
No other flavors.
That is a brutal reduction of complex economics into just, like, physical truth. I mean, every single thing we consider part of a modern society, advanced healthcare, schools, the server farm hosting this audio file, is essentially just transformed energy.
The thermodynamics of an economy literally dictate that if energy becomes fundamentally more expensive or less reliable, the total wealth of the society mathematically has to shrink. Energy isn't just a sector of the economy, it is the economy.
Right.
When the price of energy doubles, it cascades into the price of fertilizer, which doubles the price of food, which drives inflation, which crushes consumer spending.
So the critique from the source is that society claims to want a completely green transition, but we are sort of plugging our ears and closing our eyes to those inevitable trade-offs.
Exactly. Keyes points out that we never talk about the consequences. He uses very stark examples. He says, if we commit to this incredibly expensive transition, we have to look citizens in the eye and say, okay, less money for elderly care, The quality of our education system is going to drop. You'll have fewer family vacations.
Man.
Because that 269 billion euros has to come from somewhere.
And politicians rarely want to acknowledge that brutal invoice, right?
Rarely, if ever.
But heavy industry doesn't have the luxury of ignoring the math. Rob brings in some devastating price discrepancies to illustrate this. According to the source, the price of gas in Europe is currently 2 to 4 times more expensive than it is in the United States.
Which is huge.
Yeah. And the price of electricity is twice as high in Europe as it is in other parts of the world.
It's an enormous gap.
I want to pause on that gas price discrepancy because it really highlights the physical mechanics of energy. Why is it 2 to 4 times more expensive? I mean, it's not just corporate greed, is it?
No. Oh.
In the U.S., gas is extracted and moved through a network of domestic pipelines directly to a factory. It remains a gas the entire time.
Right.
But for Europe to import that same American gas to replace Russian supplies, the physical logistics are just insane.
The mechanics of liquefied natural gas, or LNG, they are truly staggering. To move gas across an ocean, you first have to build massive, multi-billion-dollar coastal facilities. Then you have to supercool that gas down to minus 162 degrees Celsius.
Wait, minus 162 degrees?
Yes.
The amount of energy required just to run the refrigeration process is massive.
Massive. And it shrinks the volume of the gas by about 600 times, turning it into a liquid.
Okay.
Then you load it onto highly specialized, heavily insulated tanker ships. You burn more fuel to sail it all the way across the Atlantic. And when it arrives in Europe, you have to build another massive facility to slowly heat it back up and regasify it before you can even put it into a pipeline.
That is wild. So every single step of that thermodynamic nightmare adds a massive premium to the final price.
Every single step. So when a European chemical plant or a steel mill looks at their balance sheet, energy isn't just a line item. It is their primary cost.
Right.
If your energy costs are suddenly quadruple what your competitors in America are paying because of this LNG supply chain, your business case basically evaporates overnight.
And the result, according to the debate, is a massive industrial exodus. They specifically mention watching companies pack up and leave the port of Rotterdam, which is one of the most critical industrial hubs in all of Europe.
The contrast they draw there is stark. While the EU is busy implementing massive top-down regulations like the Green Deal, which Rob claims lacked any serious business case or even risk analysis, countries right outside the border are playing a very different game.
Yeah, the source points out that Turkey is currently building 4,800 megawatts of new nuclear power.
Exactly. So companies look at Europe, they see sky-high energy prices, grid congestion where they can't even get a connection, or remember the 15,000 businesses and endless bureaucratic regulations.
Yeah, and they just move their factories to Turkey.
Right, where they see a commitment to cheap, reliable baseline power. And this is exactly what leads to the neo-communism critique from the source.
That critique, it centers on the idea that unelected bureaucrats in Brussels aren't just setting a goal, right? Like they aren't just saying reduce emissions by 20%.
No, they are micromanaging the exact methods of how to do it. They are dictating specific technologies, timelines, penalties. They're essentially trying to centrally plan the entire energy economy.
And the argument is that this top-down command economy approach completely cripples the free market's ability to innovate and compete globally.
Exactly.
Well, if the macroeconomic picture is this grim, a grid that physically can't handle the transition, costing hundreds of billions, and energy prices causing industrial flight, is there any hope left at the individual level?
What's fascinating here is the perspective of the green innovator, Ruud, because he completely agrees with the grim assessment of the grid and the bureaucracy.
Right.
But he is wildly optimistic about what is possible from the bottom up. He claims that true energy independence is already within reach for the average homeowner.
Yeah, Ruud lays out this very specific micro-utopia. He says for about 20,000 euros, you can retrofit a home with a specific set of measures to have zero on the meter.
Zero on the meter.
Right, meaning the home becomes completely self-sufficient. It generates and stores enough of its own energy that you literally stop paying utility bills, and the investment supposedly pays for itself in 7 to 8 years.
It sounds great, but he argues that the system is structurally designed to stop you from actually doing it. He breaks down 4 massive bureaucratic blockades.
Let's hear them.
First, building and zoning authorities. You want to install a specific localized battery storage or non-standard solar setup, and the local inspector says, that doesn't fit our standard aesthetic guidelines. You aren't allowed to do that.
Wow. I can almost picture, like, the historical preservation societies completely blocking any modern green tech on older European
Oh,
homes.
absolutely.
Okay, so that's blockade number one. Blockade number two, the banks. Let's say you get past zoning and you actually need to finance that 20,000 euros.
Hmm.
Rude points out the banks refuse to let green energy installers handle the financing directly.
Because banks rely on standardized risk algorithms, a unique, customized home energy retrofit. It doesn't fit neatly into a standard mortgage product or a personal loan structure.
Right, the computer says no.
Exactly. The friction created by traditional banking protocols basically kills the momentum of the installation.
Okay, and then you hit the tax authorities. That's the third one.
Yeah.
The government relies heavily on energy taxes. If 1 million homes suddenly drop to zero on the meter, well, the tax base evaporates.
Poof. Gone.
So the fiscus starts looking for ways to tax self-generated power, or they levy massive fixed grid connection fees just to protect their own revenue streams.
And finally, the energy companies themselves. I mean, if you become self-sufficient, their centralized business model selling you power every single month, it becomes obsolete.
They're facing a utility death spiral.
Exactly. So they lobby aggressively to maintain their relevance. They push back against policies that would empower decentralized generation because it's a threat to their existence.
Rude uses this vivid image of a street in The Hague where on one side you have the government ministries and on the other, the massive industrial sector lobbies. And they're basically fighting for their own survival, not the independence of the consumer.
Yeah.
And here's where it gets really interesting. Rude uses a powerful historical analogy. He takes us back to the early 1900s, to the Wright brothers.
I love this analogy. Back then, the idea of human flight was considered completely absurd. You had massive, heavily funded government projects trying and failing to build flying machines.
Yep.
But the actual breakthrough came from two bicycle makers in a wooden shed in North Carolina.
Right. In one shed, they fixed bikes. In the other shed, they were building a wonder. And at first, it was just, a weird contraption. But the moment it lifted off the ground, the speed of the transition was mind-blowing.
It was exponential.
Rude points out that from that very first fragile flight, it took just over 10 years before 350,000 airplanes were flying in World War I. 10 years.
It's incredible. And Rude's argument is that scattered across the country right now, in sheds and small enterprise workshops, we have the modern-day Wright brothers. We have innovators sitting on new battery tech and efficiency systems that could flip the energy system upside down, if they were allowed to scale, rather than being crushed by ministries and lobbies.
So if this bottom-up innovation is being systematically blocked, what is the government forcing us to do instead?
Well, the source points to the National Heat Program as the prime example of these top-down mandates. Municipalities are going to force citizens to install fully electric heat pumps by 2050, moving completely off natural gas.
And Bert, the investigative thinker, he is just exasperated by this. He points out the staggering irony that the Netherlands has a pre-existing, incredibly dense, perfectly functional natural gas infrastructure.
The pipes are literally already in the ground.
Right, and domestic gas is practically free to extract, minus distribution. But because of political mandates, the government is deliberately abandoning that infrastructure. Instead, they force citizens to buy expensive electric heat pumps.
And let's be real about the physics here for a second.
Yeah.
A heat pump in a poorly insulated, older European home works incredibly hard. It draws massive amounts of electricity, putting even more strain on that congested electrical grid we just talked about.
The one with the 15,000 waiting businesses.
Exactly. And to make up for the energy shortfall, Europe then imports that massively expensive, super-cooled LNG from the U.S.
It creates this awful feedback loop of inefficiency, which leads to one of the most provocative questions raised in the entire deep dive.
And this is a big one.
Are our climate measures actually destroying the natural environment?
Yeah. Rob makes a really crucial distinction here that we often muddle in everyday conversation. He separates climate, environment, and nature.
We do treat them as the exact same thing, but they aren't.
No, they aren't. Measures designed to help the climate, like reducing CO2 emissions, are frequently in direct conflict with protecting the environment and preserving nature.
Take wind energy. To meet the 300 gigawatt European plans, 30 gigawatts are slated to land in the coastal province of Zeeland. Rob points out that the North Sea, which is really the Netherlands' only vast nature reserve, is going to be turned into a permanent industrial construction site.
Think about the physical reality of building an offshore wind farm. You are driving massive steel piles deep into the seabed using hydraulic hammers.
The acoustic shock waves alone.
They can permanently deafen marine mammals. You are laying thousands of miles of high-voltage cables, industrializing a wild ocean ecosystem. You might be lowering CO2 for the climate, sure, but Rob literally calls it ecocide against nature.
Wow. Ecocide. And the source also attacks the environmental reality of solar panels. At the end of their life cycle, traditional solar panels are highly toxic and incredibly difficult to recycle.
Yeah, you have heavy metals embedded in glass and plastic. We are essentially creating a looming mountain of toxic e-waste.
And the supply chain issue is brutal. I mean, to build these millions of solar panels and electric vehicle batteries, you need raw materials, lithium, cobalt, rare earth metals.
And who controls those?
China controls the vast majority of those supply chains. The source points out the ultimate irony here. China built 600 new coal-fired power plants to manufacture the very green solar panels and EVs that Europe is buying.
Let that sink in. The global emission reductions claimed in Europe are essentially being offset by the massive expansion of coal power in China used to manufacture our green tech. It's an accounting trick. It ignores the holistic global impact entirely.
And to top it all off, we have the physics of the grid backup problem. Bert hammers home a fundamental rule here. On a power grid, the supply of electricity and the demand for electricity must match exactly every single second.
Because electricity is not like, a pile of wood you can just let sit in the corner for later.
Right.
If supply and demand don't match, the frequency of the grid, which operates at a strict 50 hertz in Europe, begins to fluctuate.
And if it drops too low or goes too high,
Physical machinery will literally tear itself apart. So the grid automatically shuts down to protect itself, resulting in cascading blackouts.
historically we managed this with the what they call the spinning mass of massive centralized turbines in coal or gas plants. The sheer physical weight of those spinning turbines provided momentum.
Inertia.
Inertia, right.
Yeah.
That kept the grid stable even if there was a sudden spike in demand. But wind and solar don't provide that same physical inertia.
And worse, they are entirely unpredictable. A cloud covers the sun or the wind stops blowing, and gigawatts of power just vanish from the grid instantly.
Just gone.
Gone. And because there is no reserve, you must have a backup system capable of providing 100% of the grid's capacity at the drop of a hat.
Meaning you essentially have to build and maintain an entirely separate, fully functional fossil fuel grid.
Usually fast-ramping gas plants.
Right. Just to sit there on standby, burning fuel just to stay warm, waiting to catch the grid when the wind dies. We aren't just paying for a green grid. We are paying for two entirely overlapping energy systems.
Which is exactly why the panelists argue the math of cheap renewable energy is so misleading. When they say wind and solar are cheap, they only count the cost of the panels and the turbines.
Right.
They don't factor in the $269 billion to upgrade the decentralized grid, nor the cost of maintaining a 100% redundant fossil fuel backup system.
So if top-down mandates are crushing, and forced heat pumps are foolish, and wind and solar destroy nature while requiring a double grid, what do they suggest we actually do?
This raises an important question, and the source does pivot to real alternatives. The strongest advocacy in the debate is for a massive renaissance in nuclear energy.
Okay, nuclear.
But before they get into the technology, they frame the scale of the problem in a way that is really eye-opening. We obsess over the electrical grid, right?
Constantly.
But electricity only accounts for 22% of our total energy consumption.
That statistic stopped me in my tracks when I read it. 78% of the energy we use, heavy industry, shipping, aviation, fertilizer production, is still fossil fuel-based.
Exactly.
If we are struggling to manage just the 22% that is electrical, the idea that we can simply electrify the other 78% using unreliable wind and solar is, well, mathematically impossible.
It just doesn't compute. So Rob advocates heavily for SMRs, small modular reactors.
Right, instead of building those massive bespoke nuclear plants that take 20 years and face endless delays.
Exactly. Companies like Rolls-Royce are producing standardized 470-megawatt reactors for about 2.3 billion euros.
And the genius of the SMR is where you put it. Because they provide stable, continuous baseline power, you can plug them directly into the existing thick pipes of the centralized electrical grid.
Yes. You completely avoid having to spend that $250 billion euros ripping up the decentralized grid.
But the immediate pushback to nuclear is always the waste, right?
Always. But the panel points to next-generation tech, specifically a Dutch startup called Horizon, working on molten salt reactors.
I really want to break down the physics of a molten salt reactor because it sounds like science fiction to me.
It does, but it's very real.
Unlike a traditional reactor that uses solid fuel rods cooled by highly pressurized water, a molten salt reactor dissolves the nuclear fuel directly into a liquid salt mixture.
And the safety profile of that is entirely different.
How so?
In a traditional water-cooled reactor, if you lose power to the cooling pumps, the water boils off, the solid fuel rods melt, and you get a disaster like Fukushima.
Right.
But a molten salt reactor operates at normal atmospheric pressure. It doesn't need to be highly pressurized. And more importantly, it naturally self-regulates its temperature through basic thermal expansion.
Right. Because if the liquid salt gets too hot, the fluid physically expands.
Exactly.
That expansion pushes the radioactive atoms further apart from each other, which naturally slows down the nuclear chain reaction. It basically cools the system down without any human intervention or computer software.
It is a walk-away safe system dictated strictly by the laws of physics.
And the kicker is the fuel source. These reactors can use thorium, or they can literally be fueled by the existing nuclear waste from older traditional plants like Borsel in the Netherlands.
Yeah, through a process called transmutation, they essentially eat the long-lived radioactive waste.
They extract more energy from it.
Exactly, leaving behind a byproduct that decays much, much faster.
So we have a technology that provides stable baseline power, physically cannot melt down, and consumes our existing nuclear waste.
It sounds perfect.
But the source laments that all the funding and political will is stubbornly fixated on wind and solar, starving these advanced nuclear projects.
And that's the massive centralized solution. But the source also highlights some fascinating grassroots innovations. Take the salt batteries in Arnhem.
Oh, this was super interesting.
Innovators have taken an old abandoned bunker and are converting it into a facility to store heat energy using phase-change salt batteries.
Right, so instead of relying on toxic lithium mined in China, they literally use salt. When you heat the salt, it melts and absorbs a massive amount of thermal energy. When it solidifies, it releases that heat back. It's brilliant. Localized storage.
It is brilliant, but it's technically against national regulations.
Of course it is.
The strict, inflexible national laws don't have a checkbox for innovative salt battery in a bunker. So the local mayor of Arnhem, Mark Couch, is having to actively protect his own municipal civil servants from the national regulators in The Hague just to allow this experiment to exist.
The local government is having to go rogue against the national government just to permit green innovation.
It's absurd.
There's another example involving cows in Overijssel that perfectly illustrates how siloed bureaucratic thinking just ruins holistic solutions.
Oh, the biogas example.
Yes.
The Netherlands has a massive political crisis regarding nitrogen pollution, which is largely blamed on cow manure.
Right.
Simultaneously, they have an energy crisis, trying to replace Russian gas. So an innovator proposed a synergistic solution: take the cow manure, process it locally on farms through anaerobic digesters, and produce biogas.
Anaerobic digestion is such fascinating biology. You put the manure in a sealed tank with no oxygen. Specific bacteria break down the organic matter, and in the process, they release methane gas.
And you capture that gas.
Right? You capture it, and boom, you have domestic, green biogas to replace Russian imports.
It's incredible. You solve the nitrogen crisis by processing manure, you produce energy, and the remaining byproduct is an incredibly rich organic fertilizer.
Meaning you don't have to import artificial fertilizer, which itself requires massive amounts of natural gas to produce.
Exactly. It is an elegant, totally circular solution.
But according to the debate, it gets immediately blocked by powerful sector lobbying.
Naturally.
The artificial fertilizer companies and the electric heat pump lobby, who basically want to kill anything with the word gas in it. They whisper in the ears of the regulators, and the project is buried.
It's not a technical failure at all. It is a failure of entrenched bureaucracy protecting its turf.
Right. Which brings us to a final point that I think really encapsulates the frustration of these panelists. The interviewer asks about Elon Musk and SpaceX beaming solar energy from satellites down to Earth. And Bert completely dismisses it as utopian wishful thinking. Like, why look to science fiction solutions that involve polluting low Earth orbit with satellites and dealing with the massive energy loss of beaming power through the atmosphere, when grounded, physical solutions are staring us right in the face?
I mean, we have molten salt reactors that eat waste. We have bunker salt batteries. We have circular biogas systems ready to deploy tomorrow.
Tomorrow.
But the Musk vision is seen as the ultimate distraction from doing the hard, pragmatic work of actually reforming our systems to allow real innovation.
So what does this all mean? The core conflict that emerges here is pretty clear. We are trapped in a transition driven by top-down, centralized bureaucratic mandates that are economically crushing based on flawed grid physics and forcing environmental compromises.
And on the other side, you have the bottom-up innovators, the engineers, the farmers, the startups. They have pragmatic solutions, but they are systematically locked out by vested interests, risk-averse banks, and inflexible zoning laws.
And this conflict isn't abstract for you, the listener. It dictates your monthly energy bill. It dictates whether your country's heavy industry stays or flees to Turkey, and whether you'll be forced to buy a heat pump or allowed to innovate your own home's efficiency.
It's really a call to question the mainstream narrative. You can't just slap the word green on a policy and automatically assume it's viable. We have to look at the underlying mechanics and the true costs.
Think back to 1903. The birth of aviation didn't come from a top-down government mandate or a bureaucratic committee trying to optimize faster horses.
No, it didn't.
It came from two bicycle mechanics experimenting wildly in a wooden shed, far away from regulators who would have definitely said their machine wasn't up to code.
Innovation requires friction, freedom, and the ability to challenge the established order.
Absolutely. So as we face this global energy crisis, where do you think the paradigm-shifting solution will ultimately come from? A multi-billion-dollar mandate from Brussels? Or the modern equivalent of that bicycle shed, an illegal salt battery hidden in an old bunker protected by a rogue mayor quietly waiting for its moment to take flight? Thank you for taking this deep dive with us. See you next time.